All right, today I'm going to be going over questions 1, 3, 11, and 14 for my test. I have a brief question written above it that sums up what the actual question was on my test. So my first one is, show the decimal 2.315 is rational by representing it as a ratio of integers. So it's important to note that our number 2.315, that only the 1 and the 5 are repeating. So what we want to do is make this 2.315 into a ratio of integers. And an integer is a number that is not, or won't have a repeating number after it. So what we're going to start with is 2.315 with our 15 repeating. So what we first want to do is get it to where only the 15 is going to be on the right hand side of our decimal. So what we do is move over ones into the tens. We have then done 10n, because it's important to know that we have gone over a place value. And then we're going to write what the place value is that we came up with. And then what we're going to want to do, because the 1 and the 5 keep repeating, we want to get this the 0.15 out of our bottom ratio. So we are going to move our decimal over 2 more times. And if you look up here, in total will be 1, 2, 3 times, which will leave us with 1,000. And then we're going to write out our new number. And we are going to subtract them from each other. So if we take 5 minus 5, 0, 1 minus 1, 0. 5 minus 3 is going to be 2. 1 minus 2, we are going to need to borrow from our 3, so it'll then become 11. 11 minus 2 is 9. My 3 then becomes a 2. 2 minus nothing is 2, and 2 minus another nothing is 2. And you come over here, and if we're subtracting our 1,000 minus our 10n, we will come out with 990n. Now we want all of our variables on one side, our numbers on the other. So what we're going to do, because 990 is multiplying by n, we are going to divide 990. And up here, we will be left with n equals 2,292 over 990. And here you can see that we no longer have repeating decimals or decimals that continue. We have 2 integers represented as ratio. Moving on to our next rule, or to our next problem, will be finding Latifa's rule. And what we're going to do is find a pattern so that when we get an input, we'll know what our output is by an equation. So if we look at this one to begin with, we know that if you take, we're going to look at this pattern here, we'll take 3 times 3, because if you look over here, we are adding 3 each time. And we are going to do 3 times 3, and so that'll come out with 9. And then if you notice, if you subtract 1, you get 8. If you multiply 4 by 3 equals 12, subtract 1 equals 11. 5 times 3 equals 15, minus 1 equals 14. So that works for, this will be our first equation. Our second one will be 3 times 4 minus 1. So what we can do is represent our numbers here as n, leaving us with the equation 3n minus 1. So any input that you'll put in for a value will give you your output. For example, 3 times 10 equals 30, minus 1 equals 29, giving us Latifa's rule for her first one. Now if we come over here, instead of multiplying by 3, if we look at the pattern, we have 0 and 1. Well, from 1 to 10, we are jumping up 10. From 10 to 26, we're moving up 16, and so forth. So there's not a pattern in our addition. So what we can do is look at our multiplication. So if we have 0 times 0 equals 1, so here we are adding 1. If we did 3 times 3 and then added 1, we would get 10. And if we did 5 times itself plus 1, we would get 26. So our rule for this pattern is going to be this number to the square root plus 1. So you'll take your input, square root it, and then add 1. And you should get your input. So if we take 8, for example, square root it and add 1, we should come up with 64 plus 1 equaling 65. Our next problem we are going to be looking at is chirps a cricket makes in 15-second intervals, and it is related to T, which stands for temperature. So down here at our plot graph, we have T standing for temperature, so this one will be temperature. And we can see up here, C, that this is going to stand for chirps. So our first problem for A is estimate the input for the temperature of how many chirps are going to happen when the temperature is at 90 degrees. So it's going to be an estimation. If we took and drew 90 straight up, and then just drew where it's going to cross perfectly across, it's going to be about 50 chirps, leaving us a plot here. Be approximately about 50. Because we can tell here that at 50 degrees temperature, we were about 10 in between 20. You're going up to 60, you're about 20 and 30. So now we are going to solve for the temperature at 20 chirps. So if you come over here, we're going to start at chirps. So our output, and at about 20 chirps, we are at about anywhere from 50 to 60. So we'll say approximately. On our 60, we actually have a chirp where 50 is below, so we'll do approximately 60. For our final problem, we are going to look at the probability of rolling 2 die. So if 2 dice were rolled, what is the probability that the sum of the number on the die is 5 or that the die shows doubles? We can do this by showing a tree diagram, or we can put it into a chart. A chart's easier to look at, so we will put it in a chart. So what we'll do is have one set of die going one way and the other set of die going the other way. And there's 6 faces on a die. And then we'll come down over here. Draw some lines here to keep us. All right, so we are going to look at the difference of the 6 dice being rolled together. So on our first roll, we have the probability of getting 1 and a 1. We have the probability of getting a 1 and a 2, 1 and a 3, and we'll go ahead and fill out the whole chart. All right, so here's our chart of all the possible outcomes that we can get when rolling 2 die together. So our question is specifically asking that the sum of numbers on the die is 5. So we'll look at that one first. So we know that obviously if our face is showing 6, it is more than 5. So we will eliminate this row. We will also eliminate this row here. We know that if we are starting at 5 and adding anything to it, that it's going to be more than 5. So we'll cross out our rows of 5 as well. So now we have narrowed down our categories here, and we're going to look at all the different numbers that equaled had 5. So 1 plus 1 does not. So for example, if we're going down, 1 and 5 does. We have 2 and 3. We have another 3 and 2. We have 4 and 1. And that looks like all of our possible outcomes. We have 6, 6, 4, 3, 4, 4. So for the first one, and if you count all the probabilities that we did, how many trials it took to get all the outcomes, it is 36. We can find this out simply by multiplying 6 faces times 6 faces of die. So our bottom number will be 36. And we have just found out that the sum of numbers that can equal 5 is 4. The next part of our question asks, what's the probabilities that it shows doubles? So we'll come back here and count all of our doubles up. So we're going to have to recount in the rows that we just eliminated. And if we look here, we notice a pattern that all of these are the ones that show doubles. So that shows 1, 2, 3, 4, 5, 6. And we still did 36 trials. So what we're going to do is add them together. We show 6 here. 4 plus 6 equals 10. And our denominator stays the same, leaving us with the probability of 10 out of 36.